So this is lesson number 44 in Algebra 2, and it's called Solving Right Triangles. And this will probably take a couple videos to get us through here. Now, what I mean by solving right triangles is that we take this picture, and this is from example 44.1, and we have 6 parts to a triangle. We have 3 angles, and we have 3 sides. We always know one of the angles in a right triangle is 90. Okay, so then we have to find the other 2, and then we've got all 3 sides. So solving the right triangle means we find all 6 of the angles. And obviously, since one's a right triangle, we don't really worry about that. So we find 2 angles and 3 sides, given the information that they give us. So one of the things that we do, first of all, probably the easiest would be to find angle B. So angle B would be equal to 180 degrees minus 90, which one of the things you can do is we can just get rid of that, because if we know this is 90, then if we add up the other 2, we know we're going to get 90 when we do that. So actually we can write this as 90 minus 24. So that gives me, what, 66 degrees for this angle right there. Okay, so that's the first bit of information that we're able to find. Now we're going to try to find h and y. Now, a lot of times you'd use Pythagorean, but in order to use Pythagorean, you have to have 2 of the sides, and we don't. We only have 1 of the sides. So this is where trig functions come in. We choose either this angle here or this angle here. Since we know that B is 66, we can choose B if we want. So we choose either one of those angles. It doesn't matter which one. You just decide which one you're going to use. And then, well, let's just use B since I've got it written up there. So let's solve for, let's find out what h and y are compared to B. Alright, so if we look at B, what information do we know? We know the line segment across from B, or we know the line segment opposite B. So we need to use a trig function, whether it be sine, cosine, or tangent, that has in its ratio opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent, SOHCAHTOA. Alright, we got to find one that has the opposite as one of its segments. So it's going to have to either be the tangent, because that has an O, or the sine. And then the other part of it is unknown. We don't know what y is, which is the adjacent angle, nor do we know what h is, the hypotenuse. So we can pick either one of these to find our answer. So let's do tangent. Like I say, it doesn't really matter. Tangent of 66 degrees equals opposite over adjacent. The opposite is 9.5, and the adjacent is y. We don't know that. So you take your calculator and you plug in the tangent of 66 degrees, and then you solve for y. So the tangent of 66 degrees is 2.2460. So I'm just going to put that there, tangent of 66, using your calculator. And then we solve for y. So when you're solving for y here, in this kind of a problem, this might make it easier. When the variable is on the bottom, trade places with this. Just switch those 2 around, and you don't have to really do any algebra. I mean, you can multiply both sides and do all that, but it's easier just to switch these around. And now we have 9.5 divided by 2.2460. And therefore your y is equal to 4.23. So the length of y is approximately 4.23. Okay, if we, and I said approximately, so make me little squiggles there, because we rounded this number, the tangent of 66. That is an unending decimal, so that makes your answer a little bit off. So we're estimating there. If we were to use the sine, remember I said we could use the tangent or the sine. I take the sine of 66, and that's going to be opposite over hypotenuse. Alright, so that being the case, we take the sine of 66, and my calculator gives me 0.9135 equals 9.5 over h, and again we switch them around. H equals 9.5 over 0.9135, and I get for a measurement of h 0.9135, about 10.4-ish for the length of the hypotenuse. Okay, so probably the trickiest part here is finding out which trig function you use to find the sides. Now remember, when you're only given one side and you're given some angles, you're going to have to use trig functions in order to find it, and that's called solving the triangle. So we'll keep doing a couple of these till you get the hang of it. So this is example 44.2, find the missing parts of the triangle. So what we're looking for is B, M, and X. Alright, so we will find B again, just like we did in the past one. We take 90 minus 35 is going to be 55 degrees. So B is a 55-degree angle. Alright, next thing we're going to do is look for X and M. So we can use sine, cosine, or tangent. Doesn't really matter which one you use, except here they're giving us the hypotenuse. So I need to use a trig function that has the hypotenuse in it. Doesn't matter which one. Cosine is adjacent over hypotenuse, opposite over adjacent, and opposite over hypotenuse. Alright, so I've got a choice of this one or this one because I'm given the length of a hypotenuse. So again, it doesn't matter if I use the 35-degree angle or the 55-degree angle. Let's use the 35 now. And what do you want to find, the X or the M? Let's find the X. So we're finding the angle, or the line that's opposite our 35 degrees, and we're using our hypotenuse. So what is opposite over hypotenuse? Sine. Sine of 35 degrees equals the opposite over the hypotenuse. In fact, let's make this the opposite they have is X. So let's call it X instead of O. It almost looks like a 0. Alright, so the sine of 35.5736-ish equals X over 14. Now, notice here, my variable is on top. So because my variable's on top, remember when the variable's on the bottom, we switch these two? When the variable's on top, you just take this 14 and put it over here and multiply it. Those are kind of the two methods to do that. And then we take 14 times the sine of 35, and that gives me X equals 8.03. So 8.03. Alright, so let's find M. M can be found using Pythagorean since we know two sides, but I think it's easier just to use these trig functions. So M, as far as where it's located, it's adjacent to the 35. So we can use any of the trig functions that have to do with adjacent. We can use cosine of 35 is going to be the adjacent over the hypotenuse, and then we'll put the 14 over here. Remember how I did that when it was down here in the bottom? And I take the cosine of 35, multiply it by 14, and that gives me the length of M. Alright, let me show you something else here. Let me get rid of all my scratchings and see almost all of them. What else I can do? I found out that, well, I know B is 55 degrees. What if I wanted to find M using 55? Well, M is opposite. So I have an opposite that I'm looking for, and I'm given a hypotenuse. So I'm looking for sine, because that's opposite over hypotenuse. So if I'm looking for M, it'd be M over hypotenuse. So the sine of 55 degrees equals M over 14. Okay, so then, again, because this is on the bottom, I multiply it by my sine of 55, and that's equal to M. So sine 14 times sine of 55, you put that in your calculator, get that, times 14, and again you're getting an estimate, 11.47. Okay, that should have been what we got pretty close when we were using the 35. And we found the cosine of 35 is adjacent over hypotenuse. So again, we were looking for M, so it's an adjacent one now. And our hypotenuse is 14. Put our 14 there. Get rid of it there. We take cosine of 35, and we get 11.47. So I get the answer both ways. So it doesn't matter whether you use cosine or sine or tangent, as long as you do it correctly. Now, these are pretty new. I'm not expecting you to get these down perfect the first time. So take some time, play around with them, be confused. That's okay. Ask me questions, and I'll help you along with this. All right, let's look at one more, and then we'll be done.